Hi everybody! Welcome to Chem with the Girls. In this video, we're going to be focusing on Newman projections. So far in chemistry, we have all become very familiar with bond line notation. It's a simple way to represent molecules on a 2D plane. Newman projections are just another way to represent those same molecules, except they focus on a single carbon-carbon bond. This unique perspective allows us more insight into the placement of individual atoms and their relative positions to one another. Let's start with the simple hydrocarbon, ethane, CH3CH3. When starting a Newman projection, it's imperative you know the perspective from which you are viewing your molecule. For ethane, let's view it from the left. We have two carbons, carbon 1 and carbon 2. Carbon 1 will be represented by a small dot here in the center. Carbon 2 will be represented by a larger circle in the back. Like I mentioned before, when you're starting a Newman projection, you are looking straight down a bond, which means one atom will reside directly in front of another. In this case, because we are viewing ethane from the left, carbon 1 will reside directly in front of carbon 2. The yellow bond, drawn in the bond line notation, cannot be seen in the Newman projection because it is directly behind carbon 1. As we know, carbon can form 4 covalent bonds within a molecule. Whenever you're looking down a carbon-carbon bond, one of those bonds will be occupied by the carbon in the back, leaving 3 hydrogens to be bonded to carbon 1 and carbon 2. For carbon 1, you have 3 hydrogens shown in red, drawn as such. The bonds themselves will extend from the dot, carbon 1, to each hydrogen in a Y shape. The hydrogen connected to carbon 2 will be drawn in blue, and they will also extend in a Y shape, but not from the dot in the center, from the circle which represents carbon 2. You may be wondering why the Ys are oriented in the position they are. When you draw ethane with the wedge and dash model, it's apparent that hydrogens are not all in the plane of the paper. Some are coming towards you and some are going away. For carbon 1, it's clear that 2 hydrogens are bonded above the carbon and 1 is bonded below. This hydrogen is coming out from the plane of the board. On the Newman projection, that is represented as coming out from the right. The other hydrogen above carbon 1 on the dash is going into the plane of the board. This is represented on a Newman projection as coming out to the left. The last hydrogen in the plane of the board is coming straight down. This is represented on a Newman projection like this. The same principle follows with that of carbon 2. 2 hydrogens are bonded on the bottom of the carbon and 1 hydrogen is bonded to the top. The one on the dash is coming out to the left. The one on the wedge is coming out to the right. And the one in the plane of the paper is coming out straight up. Let's draw that nicer. Straight up. That is how you draw the Newman projection for ethane. For our second example, we're going to move on to butane, which has a slightly longer carbon chain than ethane, it being CH3, CH2, CH2, CH3. The longer your carbon chain, the more important it is to determine the perspective from which you are viewing your molecule. In butane, we have 4 carbons: carbon 1, carbon 2, carbon 3, and carbon 4. Once again here. We are going to be drawing a Newman projection based on the 2,3 carbon bond, viewed from the left, meaning this perspective. Carbon 2 will appear in front, which is represented by the small dot. Carbon 3 will be in the back, represented by the larger circle. I've drawn out ethane here once more to show how similar its structure is to that of butane. Other than this hydrogen being replaced with this methyl group, similar to this hydrogen and this methyl group, nothing has changed, and the Newman projections will remain very similar to one another. All the groups and/or atoms bonded to the front carbon will appear in red, in this case, carbon 2. We have 2 hydrogens bonded above and 1 methyl group bonded below. Still connected to the center dot representing the front carbon in a Y shape. The atoms and groups bonded to the back carbon, carbon 3, will be represented in blue, CH3 bonded at the top, and the 2 hydrogens bonded below. These also connect in a Y shape extending from the large circle rather than the center dot to represent that they are coming from carbon 3 and not carbon 2. The orientation of the Y shape is the same explanation as ethane. For carbon 2, we have a hydrogen coming out towards us on a wedge, being represented by a hydrogen coming out to the right. We have a hydrogen on a dash going into the board, represented by a hydrogen coming out to the left, and a methyl group coming straight down in the plane of the paper, represented here. The same principle follows for carbon 3. We have a hydrogen on a wedge coming towards us, represented by coming out from the right. A hydrogen on a dash, represented going into the board, seen on the Newman projection, is coming out to the left. And a methyl group going straight up in the plane of the paper, represented here. That is the Newman projection for butane. For our final example, we'll be looking at 2-bromo-3-methylpentane. This molecule has a 5-carbon chain, 1, 2, 3, 4, 5. Once again, 1, 2, 3, 4, 5. For our Newman projection, we'll be focusing on the 2-3 carbon bond. Looking at it from the left, meaning this perspective. Carbon 2 will be in front, represented by the small dot. Carbon 3 will be in the back, represented by the large circle. Once again, we can look at ethane to get a rough structure of what our Newman projection will look like. This hydrogen was replaced with a methyl group, similar to butane. This hydrogen was replaced with a bromine. This hydrogen was replaced with a methyl group. And this hydrogen was replaced with this entire group, CH2, CH3. Other than the changing of these groups, the structure of the Newman projection will be very similar to ethane. We'll begin with the atoms and groups bonded to the front carbon, carbon 2. We have a bromine bonded above, along with a hydrogen, and a methyl group bonded below. Once again, these will extend in a Y shape from the center dot representing the front carbon, carbon 2. The atoms and molecules bonded to the back carbon, carbon 3, shown in blue. The group CH2, CH3, bonded above. Hydrogen bonded below, along with an additional methyl group. These will extend in a Y shape from the large circle, representing that they are coming from carbon 3. And finally, the orientation of the Ys can be explained in much the same way as ethane and butane. We have a bromine coming out on a wedge towards us, this being represented as coming out to the right. We have a hydrogen on a dash going away from us into the plane of the paper, that's represented on the Newman projection as going out to the left, and a methyl group going straight down, shown here. For carbon 3, we have a hydrogen coming out towards us on a wedge, shown here coming out to the right. We have a methyl group shown on a dash going into the plane of the paper, represented here, coming out to the left. And this entire group, CH2 and CH3, going straight up in the plane of the paper, represented here. That is how you would draw the Newman projection for 2-bromo-3-methylpentane. I hope this helps. Thank you for tuning in to Chem with the Girls. See you next time.